Hello all, welcome to the videos made on the process of interconnection or interfacing microcontroller to the devices. Here we are concentrating on interfacing a device called as a relays, basically used in any electromechanical circuits, basically to connect or disconnect the circuitry part. Talking broadly about the relays, there are basically many types available in the market. We have digital relays, we have solid state relays, we have electromechanical relays, correct? There are many types of relays in the market. Here we are concentrating on few relays. Being an electrical engineer, everybody knows the basic working of relays. Just briefing up here. There are basic type of relays like SP, ST, single pole, single throw. Then we have SPDT, single pole, dual throw or double throw. Then we have DPDT, that is dual pole, dual throw. So, if I am supposed to write the diagram for it, for SPST we will have one contact and one connection. It is basically simplest form of a relay, low cost, and it is proven to be more reliable, so it can operate at high voltages and currents. So, coming to the single pole, double throw, it will have 2 points to contact, normally closed, normally open. You will connect to any one of these. Again, this is a low cost circuit which can handle higher voltages and currents. So, these particular circuits have higher switching capabilities, and they are majorly used for many applications like the lights turn on, turn off. Basically they perform very well in cold condition, freezed up conditions likewise. Coming to DPDT, this particular relays will have two poles. I am calling those poles as C and C here, and will have two throws, again normally closed, normally open, NC, NO, NC, NO. So, you can connect to normally closed or normally open conditions. So, this can be this relay has a capability of handling two independent signals parallelly. Okay. So, these are comparatively little bit costly, and they are more prone to failures. So, DPDT switches are more preferred when you have a parallel operation to be kept in mind. So, coming back to microcontroller, this is what we are illustrating. Whatever I told you there is been illustrated here. So, you can see normally open condition with a common. Here you can see normally open, normally closed condition with a common connection. So, DPDT, two such parallel conditions, normally open, normally closed with a common connection there. This is a type of electromechanical relays. Basically, if you see here, we can say the relays are made up of a coil here. We have a coil there. Let us see one example. Let us highlight that. I have a coil part here. Okay. To make a connection, to break a connection, I have a spring, and once the contact is made, we have contacts. These are the major parts of any relays. In digital applications, we use a relay that uses up to 5 volts or less than that is also fine for microcontroller. Our intention in a relay interface is to make or break the circuit using the concept of energizing or de-energizing the coil through a microcontroller. In market, many relay ICs are available. You can choose any IC depending on the amount of voltage and current that you want to use. Say for an example, I have 5 volts power supply with 0.5 amps of current. So I can choose the IC 106462CP from the market. If I have 12 volts and 0.5 amps of current, then I can choose 138448 CP from the market. Depending on the requirements, we can choose different types of relays that are available in the market. Next coming, how do we drive this relay? Now this relay is electromechanical in nature. My microcontroller is digital in nature, whose output current especially is not sufficient for this relay to operate. So my intention is to boost up this current to the required level. To boost up this current to required level, we are using one driver called as ULN2803. This is a current driver which boosts the current, matches the current from microcontroller to the relay requirement. Correct? So since relay has one single contact, so one of the pin is sufficient. You can choose any pin. You energize the pin or de-energize the pin to close and open the relay contact. So writing a program here. So if you see here, I am using pin 1.0. So first I am setting pin 1.0. Now the relay should operate. So it can't operate at microsecond speed. So I should add a delay to it. I am calling a delay. In delay, what am I doing? I am loading random registers R4, R3 and R5. R5 is 55. I have loaded earlier in the main program. So I am decrementing each one of this, doing nothing. So I am wasting a microcontroller time. After return is executed, it goes to the next step. Now what am I doing? I am clearing this pin, sending 0. So relay will be open. Call delay. Upon return, you will keep on repeating the process. So if I send 1, the relay was closed. For some time, I am sending 0, the relay will be open for some time, and you can keep on doing this process on repetition by doing sjump me. Hope this video was useful. Thank you so much.